In this video, I want to talk about the recursive merge function from the 2015 exam. So here's the task again. So if you have two sorted lists, so for example something like 1 and 5 and 6 and 7, and another list that's maybe 2 and 3 and 8, then the task is to produce a merged sort list. So that would look kind of like 1, 2, 3, 5, 6, 7, 8, right? So that's merged, the merged version of this, and those have to be sorted to begin with. So first of all, let me write the function. So it would go like this. So there are two arguments, L1 and L2, and merge should return the merged version of both of them. So how do you approach this? So the first step would be to just say, okay, let's deal with the base case. And here I'll say, okay, so the base case is if L1 is empty, then it's very easy because the solution is just L2. If L2 is empty, then it's also very easy because the solution is just L1. So that's what I'll say. So if the length of L1 is 0, I'll just return L2. Now, the reason I'm saying copy here is that I generally really don't want to be returning lists that are aliases of the arguments. And that's because the users of this function would not necessarily know that they're getting an alias and not a fresh list. And then they might be in for a nasty surprise. So, which, they couldn't debug very easily at all. So for that reason, I always prefer to return a fresh copy of the list. Here it's a list of integers, so a shallow copy, it suffices because the deep copy of a list of integers is just the shallow copy. Okay. Now, I wouldn't take off marks for not doing this on the exam. However, you really should do it. So the other possibility for the base case is that the length of L2 is 0. And in that case, what makes sense is to return the copy of L1. So now the easy cases are done. So what's left is the recursive steps. So assume that merge works for small lists and try to use it in order to solve the problem for larger lists. So how can you do it? Well, let's look at those two lists. So how can we solve this problem? Well, we can say, okay, so 1 is the smallest thing possible. So we'll say, okay, so let's add 1 to the beginning, and then what we'll do is we'll add the merged version of 5, 6, 7 and 2, 3, 8. So what I did is I moved this one here. I took the rest of the list, put it here, and took this list and put it here. So if you merge those, that's sorted. This should go in the beginning. So done. That would do it, assuming that merge works for smaller lists. So that's great. And of course, if the situation were reversed, well, we'd put this element in the beginning, and then we'll merge this guy and this guy if it were the case that this element is smaller than this guy. So let's write it down. So what we'll say is if L1 at 0, so this guy, is smaller than L2 at 0, we need to return L1 at 0 plus merge the rest of L1, so not including the 0th element. That would be L1 from 1 and up to the end. And L2 stays the same. All right. Else we'll say we return L2 at 0 plus the original version of L1. We don't need to do anything here. And L2 starting from 1 and up to the end. That's it. Done.